Okay, so vectors are always represented with arrows. Resultants are what connect head of or tail of the first vector to the head of the last vector. Doesn't matter how many component vectors you have. The resultant is still connecting tail of the first. I did that very badly. I apologize. Let's do that there. To head of the last. And it's really easy if you use the line tool on Doceri to get a nice straight line. That's your resultant vector. Doesn't matter how much you wiggle around, doesn't matter how far you go. Now the cool thing about graphical, doing graphical solutions for vectors is that if you are very careful and you are cautious with scale, you can actually solve vector problems without doing any math. Other than the scaling math. So if we're told that someone travels, pardon the messy handwriting, if you travel 12.5 meters east, then turn and travel 5 meters at 30 degrees north of east, what is the resultant displacement? Important to note, resultant displacement must include two things. What are they? The displacement and the direction. Yeah, that displacement has to have a direction. If you just give me, 13.2 meters, that's wrong. That's half off. It's, if it's a 10-point problem, you just lost 5 points. Okay, so to scale these, what we're going to do, okay, so two things. Number one, these are actually easier on paper than on the computer. Though, if you want to try doing them on Doceri, you'll need to get yourself a good image of a ruler marked in centimeters and a good image of a protractor. The challenge is not scaling those objects when you move them. Because doing graphical interpretation of vectors relies on your scale being consistent. Now the bonus that we have, of course, is the little, the graph paper. So we can say that that graph paper is, and let's go to the medium graph paper maybe, that might be even easier. We can say that that graph paper is maybe 1 block equals a half a meter. So let's get this scaled up to the point where we're looking at, and I very often do really easy scales like 1 centimeter equals a meter, 2 centimeters equals a meter, and it keeps the math fairly simple, or 10. 1 centimeter equals 10 meters, so if you have a 60 meter vector, that's 6 centimeters. You want to keep the scaling easy for yourself. Okay, so I'm just going to use the graph paper because I think using the ruler is going to be more challenging than it's worth, frankly. So I'm going to kind of set that aside. So I have 12.5 meters of travel. That means that I need a line, if I'm saying that 1 block equals 0.50 meters, then that means that I need a line that is 25 blocks long. So I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So I've obviously run myself out of scale. That's a problem that we have on paper too. You have to really plan for your scaling. So what I'm going to do is, frankly, I'm going to start over. I'm going to change my scale because I can't fit this drawing on this screen. Sigh. I'll just get rid of that. I'm going to change back to the small blocks. And I'm still going to say that 1 block is equal to a half meter. So now I need 24 spaces. This is so much easier to do on paper. I apologize. This is the one thing that really is hard to do on a screen. So if I'm starting here, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So I'm going to do a line from there to there. That's my first vector. And I'm going to label that. And because we're talking about displacement here, I'm actually going to do D1. and that is equal to 12.5 meters east. I want to make sure I have a good arrow on that. Do not leave the arrowheads off of your vectors. If you do, you will cause yourself a world of heartache and grief. It creates lots of opportunities to screw things up. So now comes the more interesting part. I need to turn and go 30 degrees north of east. So this is where in the video I showed the little compass rose trick. You're going to want to put that compass rose right there. And you're going to need a protractor. Whoops, not like that. And you're going to set your protractor with the little 0 dot right on the corner, on the center of your compass rose. And you need to draw a line that goes out through, whoops, from that center dot out through 30 degrees. Okay. Now, here's the tricky part on this, because I can't count squares to get a 5-meter line, geometry being what it is. So I know that that's 30. Let's see, and if let me double check something here. Select scaling. No, scaling shouldn't change that. Okay. So let's get that out of the way. I'm going to need the ruler, and this is going to be, I tried really hard to get this transparent. I think I can do it this way. So if this is really challenging on the screen. So here's what I'm going to have to do. I'm going to have to go in and highlight one block, and I'm going to make that a 1/2 centimeter and scale my ruler appropriately.
Why can't you just do it and then move the arrow?
What do you mean?
Like copy and paste it.
Ah, clever. Let me try that. But let me also try this approach. Reason being, when you move stuff, it's really easy to change how long it is. So that's kind of why I'm going to all this trouble. We will try that, but I don't think it will work. So let's scale this ruler up a little bit. Okay. So at this point, 1/2 centimeter on my ruler is equal to the distance of a block. So I'm going to try really, really hard not to change. I just changed it, didn't I? Sure did. See, it's nearly impossible. This may not be possible to do on the screens. So I'll tell you what, let's walk through doing this on the board, sort of the old-fashioned way, because I think the technological difficulties cannot be overcome. So I'm going to pause this. I'll take pictures of what we do on the board, but I don't think this can be done on the screen. This is the first year I've actually tried it on the screen, and I think it just doesn't work.